Okay, so remember Oumuamua,
Oh, yeah.
that interstellar,
It's Visitor.
yeah, visitor that kind of swung by our solar system back in 2017?
Right.
It wasn't just like your run-of-the-mill space rock, though.
Yeah.
It was actually like the first thing ever that we were able to confirm
Yeah.
that came from outside our solar system and decided to pay us a little visit.
First confirmed interstellar object.
Yeah, and get this. It was accelerating in a way that basically broke physics as we know it.
Well,
Sort of.
kinda. Well, we're talking about that Astrum video.
Mm-hmm.
Oumuamua is at the heart of an ongoing battle raging within the scientific community. Again.
Yeah, it wasn't a massive acceleration, but it was definitely enough to get scientists talking and arguing.
Really arguing.
Yeah, there were some pretty strong opinions on this one.
Oh, yeah, we're talking like Harvard professor Avi Loeb.
Oh, yeah.
Who straight up said, hey, maybe this is alien technology.
He didn't shy away from that idea. No, he did not. And then you've got Daryl Seligman.
Postdoc researcher.
Yeah, who was like, no, this is just a dark comet.
A much more conventional explanation.
Right. So, I mean, are we looking at like a little postcard from E.T. out there?
Right.
Or just a weird comet that's messing with our telescopes?
It's a good question.
Yeah. So today we're going to do a deep dive into all this.
We'll try to cover it all.
Yeah, look at all the evidence, all the arguments from both sides.
You know, science is all about testing ideas, revising theories.
It's a process, right?
Yeah, exactly.
So let's rewind back to October 2017.
Okay.
The Haleakala Observatory
In
Hawaii spots this weird thing just kind of zooming through our cosmic neighborhood, right?
Just zipping right through.
And they give it a really fitting name, I think. Oumuamua.
Yeah, which means in Hawaiian, scout or first distant messenger.
And it really was a scout. It came from a whole other, another place entirely, which is crazy to think about.
Yeah.
Now, here's where it gets like really interesting. As Oumuamua was moving away from the sun,
Right.
scientists noticed that it was speeding up a little bit, but it wasn't just like a little push from solar wind or anything.
Right. It wasn't just the sun's gravity.
Yeah.
It was accelerating more than it should have been.
Yeah, more than it should have been. It was like something was giving it an extra little like
Juice.
Yeah, a boost.
A little kick.
Yeah, but we couldn't see what it was.
Right. That was the mystery.
So obviously scientists were like,
What's going on here?
yeah. So first they thought, okay, maybe it's the solar wind.
Right.
You know, giving it a bit of a push, but
that wouldn't have been strong enough.
it wasn't strong enough. Yeah.
Yeah.
And then they thought, okay, maybe it's acting like a comet,
Like a comet. Yeah.
getting a push from that ice and gas turning into vapor.
A sublimation. Yeah.
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 Like a little rocket engine almost.
Right.
But here's the thing, Oumuamua didn't seem to have a tail.
Which is what you'd expect from a comet.
Yeah. If it was a comet, where's the tail?
No tail, no outgassing, no obvious source of acceleration.
It was a real head scratcher.
Yeah.
And then Avi Loeb comes in with this hypothesis that's like straight out of science fiction.
Bold hypothesis.
He's like, what if Oumuamua is like a giant alien light sail?
An incredibly thin light sail.
Yeah. So ESA light sail, exactly. I've heard of them. But...
So imagine a giant mirror.
Okay.
Super thin.
Yeah.
Floating in space.
Okay.
And even though sunlight doesn't have any mass,
Right.
it still has momentum.
Oh, okay.
And when those photons, the little particles of light, bounce off that mirror, they transfer some of that momentum.
Yeah.
So if you have a big enough, light enough sail,
Okay.
it could actually be pushed through space by the pressure of sunlight.
Wow, like a sailboat, but with light.
Yeah.
That's incredible. And Loeb actually thought Oumuamua could be one of these things.
That was his idea.
That's a pretty bold claim, I gotta say.
It was, but it wasn't totally out there.
Yeah.
Light sails are a real concept.
Right.
Scientists are actually working on them,
Wow.
especially for interstellar travel.
Right, because you wouldn't need to carry fuel or anything.
Exactly.
Yeah.
Just use the power of the sun.
Yeah. So Loeb's theory was definitely controversial.
It got people talking.
But it wasn't completely crazy.
Not at all.
Right. It actually explained a lot of things, like why it was accelerating.
And why we didn't see a tail.
Right. If it was a super thin, light sail, we might not be able to see anything coming off of it.
Exactly.
So why didn't everybody just buy into the whole alien spaceship theory?
Well, not everyone was convinced.
Right.
Extraordinary claims require extraordinary evidence.
Yeah.
And that's where Daryl Seligman comes in.
Yeah, with a different explanation.
He proposed what he called a dark comet.
A dark comet. Okay, that sounds interesting.
Yeah, it's a really cool idea.
So what's the story with this dark comet?
Well, Seligman suggested that Oumuamua might be made of something we hadn't considered before. Hydrogen ice.
Hydrogen ice, okay.
Yeah, and the idea is that when hydrogen ice sublimates,
okay,
it wouldn't create a visible tail like comets made of water ice and dust do.
Huh. Hydrogen ice. That sounds kind of exotic.
It is. It's not as common as water ice, but it can form in those really cold, dense molecular clouds.
Oh, okay.
Where stars are born.
Yeah, yeah.
And hydrogen is the lightest element, so a comet made of hydrogen ice could be pushed around pretty easily.
I see.
Even by subtle forces.
Okay, so Seligman's thinking, okay, Oumuamua is this hydrogen iceberg.
Yeah.
And that outgassing hydrogen, that's what's giving it that weird acceleration.
Exactly.
Clever. But, were there any problems with that theory?
Oh, of course.
Yeah.
Loeb, for example. He argued that a hydrogen iceberg couldn't survive the trip from interstellar space.
Oh, right.
It would have sublimated away long before it got here.
Yeah, it would be gone, basically.
Yeah.
So what happened then? Did Seligman just give up?
No, not at all.
Okay.
He refined his theory.
Okay.
Teamed up with Jennifer Bergner.
Okay.
And they came up with a new twist on the dark comet idea.
Oh, okay.
They proposed that Oumuamua could be a regular comet.
Okay.
But with a little secret.
Yeah.
Trapped pockets of hydrogen gas.
Oh, so not a pure hydrogen iceberg.
No.
But a regular comet that's got these, hidden hydrogen boosters.
Exactly.
That's pretty smart.
And what's really interesting is that Seligman and his team,
yeah,
they actually found 6 more objects in our own solar system.
Really?
That showed the same kind of weird acceleration.
Wow.
They called them dark comets.
Dark comets. Wow. So we've gone from one weird object to a whole new class of things out there.
Yeah.
But wait, if these dark comets are just hanging out in our solar system,
right,
why haven't we seen them before?
That's a great question. Yeah. And to answer that, we need to take a deeper look at the world of dark comets.
Okay, so let's do that.
Let's do it.
So we've got these dark comets, right? They're hiding in plain sight.
Yeah, pretty much.
But how do we even study something that we can barely see? I mean...
We're in luck.
Okay.
Because we actually have a chance to get up close and personal with one.
Really?
Remember that Japanese space probe, Hayabusa 2?
Oh, yeah.
The one that grabbed those samples from the asteroid Ryugu?
Yeah.
Well, it's on an extended mission now.
Okay.
And guess what?
What?
One of these dark comets is on its itinerary.
No way. Seriously, it's going to go visit one of these things.
That's right. Hayabusa 2 is scheduled for a flyby of 1998 KY26 in 2031.
2031. Okay, so back up for a sec. Why this dark comet? What's so special about this one?
Well, for starters, it's tiny.
Oh, okay.
We're talking 30 feet across.
That's pretty small.
Yeah, it's small. And get this, it spins incredibly fast, like a rotation every 10 minutes.
Wow. So it's like a little...
It's like a tiny cosmic top just whirling through space.
That's amazing. Okay, but so what are they hoping to learn from this close encounter?
Right.
Will we finally get confirmation on those hydrogen pockets?
Confirmation would be amazing.
Yeah.
But there's actually more to it than that.
Okay.
1998 KY26 is also thought to be water-rich.
Water-rich.
Which makes it really interesting for another reason entirely.
What's that?
Future human missions to Mars.
Hold on. What does this tiny comet have to do with Mars?
Well, think about it. If we're going to send humans to Mars and eventually establish a base there, we're going to need resources.
Right, of course.
And water is essential.
Yeah.
And hauling it all the way from Earth would be incredibly expensive and inefficient.
Makes sense.
So scientists are looking for ways to use resources that are already out there in space.
So these dark comets, if they're full of water, they could be like cosmic watering holes.
Exactly.
For future Martian explorers.
Yeah, they could become crucial pit stops for refueling.
Right.
Or even provide the raw materials for water extraction on Mars itself.
Wow. That's amazing. So this little tiny spinning comet could actually help us get to Mars and maybe even stay there.
It's a possibility. This
is incredible. Okay, but let's circle back to Oumuamua for a second.
Okay.
If if Seligman is right and these dark comets are actually pretty common,
Yeah.
does that make Oumuamua less special? I mean, it was our first interstellar visitor.
Oumuamua will always hold a special place in astronomy history. It was our first confirmed interstellar visitor,
Right.
and it really opened our eyes to the possibility that our solar system is constantly being visited by objects from other star systems.
Like, we're not alone out here.
Yeah, exactly.
It's kind of freaky, but also really cool to think about.
It is pretty mind-blowing.
Yeah. So Oumuamua was like the trailblazer, and now we're realizing that it was probably just part of a much bigger...
Yeah, much bigger cosmic migration.
Yeah, and who knows what else is out there.
That's the exciting part.
It is. It really is. So we've been on this trail, right? Oumuamua and these dark comets. It's like almost like a cosmic detective story.
It really is. And we're still trying to like put all the pieces together.
Yeah. And we're trying to figure out where they fit in, you know, like in the grand scheme of things.
Right, right.
Could they be more than just, you know, these weird objects zipping through space? Could they actually be like important for how star systems evolve or even how life spreads?
That's a really interesting question.
Right.
And it's something that astrobiologists are really interested in.
Oh, okay.
Because, you know, those building blocks of life like the water, the organic molecules,
right,
they could hitch a ride on these dark comets.
Oh, okay.
And then as they travel between star systems, they could be, you know, spreading those ingredients for life.
So like they're almost like a cosmic gardeners scattering the seeds of life across the universe.
That's a beautiful way to put it.
It is pretty cool to think about.
It is.
Okay, so back to Oumuamua. We've got these two main explanations, right?
Right.
Loeb with the alien light sail.
Yeah.
Seligman with the dark comet.
Yeah.
Where are we now? Has finding all these other dark comets made Seligman's theory like the winner?
Well, it's definitely given it a lot more support.
Okay.
I mean, the fact that we're seeing objects in our own solar system acting like Oumuamua suggests that maybe it wasn't as unique as we first thought.
Yeah, yeah. But Loeb's not giving up on the alien light sail idea, is he?
I don't think so.
I mean, I kind of like that idea, the alien spaceship. It's pretty cool.
It's definitely a captivating idea.
Yeah.
And you know, we shouldn't completely rule anything out.
Right, of course.
We need that extraordinary evidence like we were talking about before.
Yeah.
But until then, it's important to keep an open mind. The universe is huge, and there's still so much we don't know.
It is pretty crazy to think about, like, just 10 years ago.
Yeah.
We didn't even know that things like Oumuamua existed.
Right.
And now we're finding out that they're probably pretty common.
It's amazing how quickly our understanding of the universe can change.
It really is.
It's a testament to science, you know?
Yeah.
The curiosity, the exploration, the constant questioning.
Yeah, that's what keeps us moving forward, right? Trying to figure out where we fit in this whole cosmic picture.
Exactly.
So as we wrap up this deep dive, I'm feeling pretty optimistic, you know?
Yeah.
We may not have all the answers about Oumuamua.
Right.
But it's really opened up a whole new world of possibilities, it feels like.
Absolutely. It's shown us that there's still so much to learn about the universe.
And who knows what the future holds.
Yeah, who knows?
Maybe we'll be able to, like, intercept these interstellar visitors one day.
That would be incredible.
Get up close, study them, maybe even prove Loeb's theory about the light sail. It's possible.
Or maybe we'll find something even crazier.
Yeah.
Something that totally changes how we see the universe.
It's exciting to think about.
It really is. It's an amazing time to be alive, don't you think? I mean, we're making discoveries all the time.
It's a golden age of astronomy.
It is. And you know, to our listeners out there, keep looking up at those stars.
Keep asking questions.
Keep exploring. You never know what you might find.
The universe is full of wonders.
It is. That's all for this deep dive. We'll catch you next time for another journey into the unknown.